Hello, everyone. Today we will be reviewing modern aquaculture and its impacts. I will start by introducing you to aquaculture for those that are unfamiliar with it, explain its impacts on both local environments and broader ecosystems, review some mitigation strategies for any harmful effects, and then provide examples of more sustainable approaches. Lastly, I'll finish with a conclusion and provide some questions to ponder. Modern aquaculture, the farming of fish, shellfish, seaweed, and other aquatic organisms, is a critical solution to meet the growing global demand for sustainable seafood. Today's practices emphasize innovation, combining traditional methods with advanced technologies like automated feeding systems, water quality sensors, and selective breeding to improve productivity. Offshore aquaculture, land-based recirculating systems, and integrated multi-trophic systems are transforming the industry to reduce environmental impacts while enhancing efficiency. As the fastest-growing food production sector, aquaculture plays a vital role in providing nutritious food, creating livelihoods, and preserving wild fish stocks. Although it has many benefits, there are some downsides that cannot be ignored and that modern developments can mitigate. Fish farms release nitrogen and phosphorus into the water from uneaten fish food and fish waste. In oligotrophic or nutrient-poor waters, this influx can cause algae blooms, leading to hypoxia and harming marine life. Some Mediterranean fish farms have historically contributed to algae blooms. Waste from fish farms often settles on the seafloors in areas of inadequate currents. This can smother benthic organisms, decreasing biodiversity and favor low oxygen-tolerant species. Studies show declines in sensitive species like sea urchins and increases in opportunistic species like polychaete worms near fish farms. Many farms use antibiotics, pesticides, and anti-fouling chemicals, which can leach into surrounding waters. Overuse of antibiotics contributes to antibiotic resistance, while toxic chemicals bioaccumulate in the food web. We create artificial habitats that attract predators like seabirds, sharks, and marine mammals. Some animals become dependent on farms, altering their natural foraging behaviors. Sea lions and dolphins have been known to break farm nets to access fish. Farmed fish occasionally escape and interbreed with wild populations, reducing genetic diversity and survival rates. In Norway, escaped Atlantic salmon have interbred with wild populations, weakening their ability to survive and reproduce. High-density fish farming increases disease risk, which can spread to wild populations. In Scotland, sea lice infestations from fish farms have significantly impacted salmon populations. Areas with strong currents helps disperse waste and minimize eutrophication. Deep water sites with good circulation reduce nutrient buildup. Integrated multi-trophic aquaculture systems combine fish farming with seaweed and shellfish, which naturally absorb excess nutrients. These IMTA farms in Canada and Norway have successfully reduced waste impacts. Traditional feeds rely on wild-caught fish meal and fish oil. Innovations like insect-based feeds, plant proteins, and algae oils reduce environmental impact. Using cleaner fishes like grasses and lumpfish can control sea lice naturally. Vaccines and probiotics have been developed to reduce antibiotic dependence. Enforcing stricter waste discharge, antibiotic use, and species introduction regulations, as well as encouraging regular environmental impact assessments for adaptive management, are two strong methods of regulation. Lake by Fisheries and Oceans Canada represents integrated multi-trophic aquaculture. The orange spots represent inorganic dissolved nutrients, the light green spots represent organic fine particle nutrients, and the larger green spots represent organic large particle nutrients. This setup utilizes nutrients in an efficient manner that allows many organisms to benefit off one another. Feel free to pause here to get a better look at the graphic. Aquaculture is vital for future food security, but must be managed responsibly. Major concerns include nutrient pollution, habitat degradation, genetic risks, and disease transmission. Sustainable solutions like IMTA, better site selection, and alternative feeds can reduce environmental impacts. Collaboration between scientists, policymakers, and industry leaders is essential for long-term sustainability. Some questions I will leave you with are, how can technology, like AI and remote sensing, improve aquaculture monitoring? And what role can alternative proteins play in reducing fish farming's environmental impact?